Hello. Today you're going to find missing angles of right triangles using trig. So all you need to know is the length of any two sides of a right triangle, and you will be able to find the missing angle. So as an opener, pause your video and find all of these measurements using the 45, 45, 90 special right triangle. Okay, so since these are 45, 45, 90s, you can find the missing sides using A radical 2. Using the triangle on the left, find the sine of 45. So we learned with respect to the angle, you can label opposite leg, adjacent leg, and hypotenuse. So the sine of 45 is 3 over 3 radical 2. Simplifies 1 over radical 2. And then we rationalize the denominator. Do the same with the triangle on the right. You get the same thing. And we talked about this yesterday, that because they are similar triangles with angle-angle similarity, the sides should all be in the same proportion. So square root of 2 over 2. And then tangent of 45, opposite over adjacent leg. And both of those should be 1-to-1 ratio because they are isosceles. Now today, you will not be given the angle. You will just know the ratios. And given the ratio, you will find the corresponding angle. So for example, you know that if the opposite to adjacent ratio is the same, then it's an isosceles triangle. So it's a 45, 45, 90. So what we've been doing is useful because you can find missing parts of right triangles with only 2 pieces of information. So today we're just going to find missing angles, and then tomorrow you will find missing sides as well. Now, a lot of you had made the mistake that 3, 4, 5 right triangles were 30, 60, 90, and they're not, because they don't have the same proportion. Well, let's find the angles for these Pythagorean triples. So I'm going to show you how to do that. So with this first triangle, the 3, 4, 5, let's start with angle A. So I'm going to show you how to do this. So one way you could do this is the tangent of angle A equals, so opposite over adjacent leg equals 4/3. So now on your calculator, you can type, so make sure, again, you're in degree mode. And now what you're going to do, so to figure out A, you actually type this in. The inverse tangent of 4/3 equals A. That's how you work backwards. You actually you take the inverse tangent of both sides. So you get A equals the inverse tan. So that's second tan inverse 4 divided by 3. And you get, as long as you're in degree mode, if you're in radian mode, it gives you the corresponding radian measure, 53.13 degrees. We'll do two decimal places. Okay. And then B, well, the angles have to add up to 180 degrees. So 180 minus 90 minus 53.13 would be 36.87 degrees. Or you could set up another trig function for that. So these are the angles that go with the 3, 4, 5. Okay. Now, let's go to this triangle down here, the 5, 12, 13. Let's use F, no reason, we're just going to pick F, and let's pick sine. See, if you're given all 3 side lengths, you can actually use any of the 3 trig ratios. So the sine of F, so let's label 12 as opposite leg, 5 is adjacent leg, and 13 is hypotenuse. Sine, remember SOHCAHTOA, SOHCAHTOA. So sine is opposite over hypotenuse. So the opposite leg over hypotenuse is 12/13. So now inverse sine of 12/13 in the calculator is about 67.38 degrees. Okay. So that's here. And then E is just the triangle sum. So 180 minus 67.38 minus 90 is 22.62. Okay, and then let's do this. Let's do the 724/25, and I'm just gonna have you do it with respect to D, and we'll use cosine. Again, you can use all three. So cosine of D equals adjacent over hypotenuse. So here's adjacent leg, opposite leg, hypotenuse. So 24/25. Okay, calculator, inverse cosine 24/25. 16.26. Okay. And then for C, 180 minus 90 minus 16.26. Again, you could use another trig ratio if you want to get this side angle. Okay, do the last triangle now. Let's, just so we're all doing the same thing, let's use tan of G. Pause the video, set it up, find the answer. Okay, so tan is opposite over adjacent leg. So so the inverse tan of 8/15 equals 28.07. So use the inverse when you're finding the angle. Okay, and then the last one by subtracting, 90 and from 180, 61.93. So those are the corresponding angles. Okay, now if you have something like this, so it says the sine of B equals 0.4848. That means the sine ratio of some right triangle is 0.4848 to 1. So then you type inverse sine of 0.4848, and you get about 29 degrees. Okay, so you just type these into the calculator. Next one, inverse cosine of 0.7431. So you type that, inverse cosine, inverse cosine 0.7431, 42. Go ahead, do 5 and 7. There you go. And then you could always check. You could say, okay, then the cosine ratio of 65 equals, and then it should be about 0.4226 to 1 ratio. Okay, and then we'll look at a few of these. So this is kind of like what your homework is going to look like. So we want to know what angle is associated with these triangles. Now, you could always use Pythagorean theorem to find the third side, but you don't need to. So what you do is, so here's the question mark angle. Now label the given sides with respect to that angle. So you have opposite leg, adjacent leg, and then the hypotenuse isn't given. So using SOHCAHTOA, to remember which trig ratio is which, we're going to use tangent, right? So the tangent of the question mark, I'll use theta, equals opposite over adjacent, 27/38. So we want to know what angle has that ratio 27/38. So inverse tan of 27/38 is about 35.4. This said round to the degree, but it's 35.39 if you round to the hundredth. Okay, so 11. Let's see. Oh, we have opposite is 14, adjacent is 29, and we don't know the hypotenuse, so we'll use tan again. Tan of that angle is 14 over 29. So what angle has that ratio? So inverse tan, 14 over 29, is about 26 degrees. We'll say 25.77 degrees. And then you could always find the other angle, because we know they add up to 180, and you can find the third side with Pythagorean theorem. Okay, 13, let's label. So the 10 is the opposite leg, the 39 is the hypotenuse, it's the longest side. So OH, that's sine. Sine of theta equals 10 over 39. Okay, type in your calculator. Inverse sine 10 over 39, 14.86 degrees. Okay, here's your next one. Pause the video, give these a try. Label, figure out the trig ratio, and then type in the calculator. Okay, the 12 is the opposite leg. The 24 is the hypotenuse. It's opposite the 90-degree angle. OH, sine. Sine of theta equals 12 over 24, which is a half. So which angle has a sine ratio of a half? This one you'll eventually have memorized when you take pre-calc. And you might know right now, based on yesterday's, but that's okay if you don't. Inverse sine of 12 divided by 24, or a half, is 30 degrees, right? That's the 30, 60, 90 special right triangle. And then 17, it's always with respect to the angle, okay? With respect to the angle. So 6 is adjacent leg, 8 is hypotenuse. Oh, that's cosine. So cosine of theta equals adjacent 6 over hypotenuse 8, or 3/4. So inverse cosine 6/8, 41.41 degrees. Okay, pause the video. Give these two a try. Okay, so with respect to the angle, adjacent leg, opposite leg, hypotenuse. Again, how do you know it's hypotenuse? Because it's the longest side. You could pick any of the trig ratios, doesn't matter. I'll pick sine, opposite over hypotenuse. Now, you could pick any of them. If you picked cosine, it would be 48 over 50. If you pick tan, it would be 14 over 48. But you'll get the same answer no matter what you pick. And that is 16.26 degrees. And then 27, let's just pick tan for the heck of it, no reason. Opposite, adjacent, 24 over 7. 73.74. And then here we go, number 23. We could use any of them again. Let's pick cosine just for practice. Adjacent over hypotenuse. Whoops. 36.87. And here, I like this critical thinking question. Find an angle, x, where the sine ratio is equal to the cosine ratio. So where will the opposite over the hypotenuse equal the adjacent over the hypotenuse? Well, that would happen when the opposite is equal to the adjacent. And what kind of triangle is that? 45, 45, 90. So 45 degrees, or pi over 4 radians. And there you go. So for practice, go ahead and do the delta math, and have a good day.